Shrouded by an unbreakable veil, on the shores of an island bathed in an ocean of space and time, a monster awaits. Its existence, a mystery, a whisper among the shadows of the universe, a story hidden within the waves of its native galaxy. Its name is WOH G64, a titan on the brink of death, desperately clinging to its final breaths. The agony of its destiny turned into the most devastating fury of the cosmos. A lament blurred within the sands of time, yet one we have managed to approach. We ventured into the heart of this colossus through light that gifted us its portrait. An image that connects us for an instant to the greatest star known. To that realm doomed to vanish, so we may bear witness to its final days. One of the most significant photographs in human history. The first snapshot of a star beyond our galaxy. The portrait of a mighty god reigning over an island of light far beyond our empire.
El 21 de noviembre de 2024, el Observatorio Europeo Austral publicó una fotografía que representaba la primera imagen en primer plano de una estrella fuera de nuestra galaxia, de una supergigante roja en las etapas finales de su vida que durante décadas nos había fascinado. Esta es la historia de WOH G64, de cómo rompimos todas las fronteras del espacio y del tiempo para cazarla, y de las confesiones escondidas en ese retrato.
During the 1970s, Sweden began actively participating in international collaborations for space observation. With strengthened infrastructure in telescopes and observatories, astronomy was gaining prominence within the Scandinavian nation's scientific community. In this context, astronomers Bengt Westerlund, Niels Olander, and Bengt Hedin undertook a project to unravel the nature of the stars shaping one of the galaxies closest to our island of light. The Swedish scientists aimed to catalog bright stars in the Large Magellanic Cloud, a dwarf galaxy located 163,000 light-years away, to understand its stellar population and evolution. Using photometric and spectroscopic data, their work focused on identifying stars with high apparent luminosity in that small galaxy, visible to the naked eye as a faint body in the southern hemisphere. The result of this effort was published in 1978 as the WOH catalog, named after the initials of the three astronomers' last names. It was a list of massive luminous stars in the heart of the Large Magellanic Cloud that might have gone unnoticed by the community if not for the fact that it contained a body that defied all conventions. Westerlund, Olander, and Hayden had just discovered what would become the largest star in the known universe. WOH G64 was a red supergiant, with an estimated radius of 1,540 times that of the Sun. A star so colossal that if placed where our Sun resides, its surface would extend beyond Jupiter's orbit. At a distance of 163,000 light-years, a star 282,000 times more luminous than the Sun was signaling its existence. It was classified as a red supergiant in an extremely advanced stage of its life. Although hidden in the shadows of a distant peninsula, we had just perceived the lament of a titan nearing its death.
WOH G64 es a día de hoy la estrella más grande conocida. Con sus 1540 radios solares, está rozando el límite teórico para el tamaño de una estrella. Pero su masa y luminosidad no fue lo único que llamó la atención de la comunidad. Cuando vimos que estaba desgarrándose, perdiendo masa a una velocidad extrema, entendimos que teníamos en ella una oportunidad única para contemplar una estrella en su lecho de muerte.
In the years following its discovery, more detailed studies heightened the interest of astronomers worldwide in WOH G64. It was in the early 1980s that infrared observations detected the presence of an enormous amount of gas and dust surrounding the star. The star was immersed in a dense cloud made of material it had expelled itself. This was the circumstellar envelope of WOH G64, newly identified through the thermal emissions of that hot dust captured by infrared-sensitive telescopes. The discovery revealed that the star was losing mass at an extremely high rate, a behavior typical of red supergiants in the final stages of their lives. These stars, despite their immense size, have a relatively low surface temperature compared to younger, smaller and hotter stars, which gives them their reddish glow. But hidden within its inaccessible core, the nucleus harbors the purest representation of hell. The forges of creation roar with unparalleled power, a nuclear energy inconceivably intense, generating a radiation pressure so immense and unyielding that it can overpower gravity, expelling material into the abyss of space. The star is roaring through stellar winds, reaching speeds of up to 100 kilometers per second. Unable to contain the violence brewing within its corrupted core, it is tearing itself apart. Its outer layers disintegrate, forming a veil of gas around it, concealing itself in its own ashes before gravity delivers its fatal embrace. WOH G64 was undergoing this very process. The dense dust envelope surrounding the star was a clear indicator of a high mass loss rate, spurring deeper studies into that cloud of material stripped from its surface. Specifically, it was discovered that WOH G64 was shedding mass at an exceptionally high rate, equivalent to the mass of a planet like Jupiter every year. Through those stellar winds, the star was evaporating at an unprecedented pace observed in the universe.
Sumado todo esto, descubrimos que estaba experimentando cambios de brillo cada aproximadamente 800 días, lo que se conoce como un ciclo de variabilidad. WOH G64 pasa por fluctuaciones periódicas en su luminosidad, en intervalos regulares, en este caso de alrededor de 2 años y 2 meses. Este comportamiento es común en supergigantes rojas en etapas finales de su vida. Pero de nuevo, esta lo estaba llevando todo al extremo.
The changes in luminosity in WOH G64 were remarkably pronounced compared to other similar stars. The intensity and amplitude of these fluctuations were unparalleled. The outer layers of the star were expanding and contracting periodically with such intensity that the emitted light varied so dramatically that we could detect these periods of brightness and darkness from 163,000 light-years away. Everything we discovered about it pointed in the same direction. WOH G64 was on the brink of death. Never before had we encountered a star so close to its demise. In it, we had a unique opportunity to witness the final breath of a god before sacrificing itself in an epilogue of devastation. For a long time, we were limited by technology that couldn't keep up with our ambitions. That vast ocean separating us from a giant reigning in the heart of a galaxy beyond our peninsula of light prevented us from fulfilling our dreams of closely observing its majesty. It wasn't until the dawn of the new century that we were prepared to fulfill those aspirations. In 2005, a team led by Dutch astronomer Jaco van Loon conducted a detailed study using data from the Subaru telescope located at the Mauna Kea Observatory in Hawaii. An analysis of the infrared readings of the distant star revealed a strange feature in the veil we knew surrounded the giant. The nebula around it did not appear to be spherical. Instead, it was markedly asymmetrical, an elongated cloud of material stripped from its surface. All simulations suggested that these envelopes should form an almost perfectly symmetrical sphere around the star. Something had to be gravitationally influencing the nebula to stretch it to such an extreme shape. But once again, we faced a barrier. That giant resided too far away, both in space and time, for us to observe its true form.
El descubrimiento de esa envoltura asimétrica alrededor de WOH G64 mostró que la estrella era inusual no solo por su enorme tamaño y pérdida de masa, tenía ciertas características que no encajaban con nuestros modelos de evolución estelar. Esto despertó un gran interés en la comunidad por obtener una imagen directa y en primer plano que revelara su estructura exacta y las dinámicas que tiene con su entorno. Algo que en condiciones normales habríamos hecho inmediatamente, pero esta no era una situación normal. Estábamos hablando de fotografiar una estrella de otra galaxia, tomar un retrato de un ente a 163.000 años luz de distancia.
The dream of capturing a direct image of WOH G64 had begun to take root, an ambition that would force us to break free from all the limitations nature had imposed on us. And to rise to the challenge, we had to take an unprecedented technological leap. As part of a joint effort led by the Max Planck Institute for Extraterrestrial Physics, in collaboration with institutions in Germany, France, and Portugal, the development of an instrument named Gravity began in 2010. An optical and infrared interferometer destined to be installed at one of the most important observatories in the world, the Very Large Telescope in the Atacama Desert, Chile. Gravity would transform the 4 telescopes into a single cosmic camera. If each individual telescope could detect objects 4 billion times fainter than those visible to the naked eye, combining them into one would yield an angular resolution of 0.002 arcseconds, equivalent to distinguishing something as small as a coin from 2,000 kilometers away. This combination of the 4 telescopes would be achieved through the magic of interferometry, a technique that synchronizes the light from physically distant telescopes to achieve a resolution comparable to using a mirror the size of the distance between them. Gravity would make the 4 telescopes, each with an 8.2-meter mirror, work in perfect synchronization. The visible and infrared light captured by each would be combined to create a virtual telescope with the power of a 130-meter diameter mirror. By overlapping the paths of light with a precision of less than a micrometer, they had exactly what they needed to separate WOH G64's primary light source from its surrounding environment, the immense dust cloud. With gravity, they had the resolution to achieve a direct image of a star beyond our galaxy. Finally, after years of efforts to install and perfect its functionality, on November 21, 2024, they delivered to the world what had been considered impossible for decades. They had captured a light that began its journey to us 163,000 years ago, long before the dawn of modern humanity. They had the portrait of that giant, a snapshot of a god desperately clinging to the throne of a galaxy. The first image of a star beyond our island of light. The first moment humanity gazed upon the life and impending death of an entity separated from us by an unfathomable ocean of emptiness. A glimpse into another realm beyond our home.
La imagen de WOH G64 no era una fotografía en el sentido estricto de la palabra. Los 4 telescopios no habían visto la estrella como lo haría una cámara. A través de Gravity habían registrado unos datos sobre sus ondas de luz, que luego fueron procesados por unos modelos computacionales que en cierto sentido sí que reconstruyeron una imagen. Además, casi todas las observaciones se habían realizado en el rango infrarrojo, porque su envoltura de gas y polvo bloquea la mayor parte de la luz visible. La imagen era más una interpretación que una representación real, pero no dejaba de ser algo increíble. Hasta ese momento, la estrella más lejana de la que habíamos obtenido una imagen directa era Betelgeuse, ubicada a 642 años luz. WOH G64 descansaba 163.000 años luz de distancia. Pero más allá del hito tecnológico, lo verdaderamente importante era lo que esa imagen nos contaba.
That close-up of WOH G64 was far more than a seemingly blurred photograph. It allowed us to glimpse the most extreme star ever discovered. A historic observation of a red supergiant nearing death as a supernova. The portrait confirmed the presence of a non-spherical envelope of gas and dust, adopting a toroidal and asymmetrical shape that did not fit our stellar evolution models. But that was not even the strangest part. One of the deepest revelations of the image concerned its luminosity. The star had dimmed dramatically in just 10 years. A decline in brightness that should not have been occurring. At least not so quickly or dramatically. This could only be explained in one way. A revelation that put astronomers in a race against time to unravel the nature of this giant. It was literally preparing to die. It was not just nearing death. It had been caught in the very act of preparing for it. WOH G64's true identity could be that of a yellow hypergiant, a phase of evolution following the red supergiant stage. A phase much closer to the end of its life, where expansion is accompanied by an increase in surface temperature, with the heat shifting the star's color from red to yellow. The transition to this yellow hypergiant phase originates from the depletion of the last elements keeping it alive. It is the approach to that iron core whose forging will no longer release energy, causing the star to poison itself. The furnaces will extinguish, and gravity will win the ultimate battle. Without nuclear reactions to sustain it, the star will succumb to the fracture of nature's fabric. Gravity will pull trillions of tons of gas into that extinguished inferno. Pressure will increase exponentially until a shockwave is unleashed, shining brighter than its entire galaxy for a brief moment. WOH G64 will die as a supernova, and all the elements jealously guarded in its heart will be released. After that gravitational martyrdom, when the nebulae in that stellar graveyard dissipate, something will remain. A ghost, a corrupted memory of its existence. A dark air with the power to destroy worlds, drain the universe's light and halt time. The pillars of reality fractured at a point, an entity defined by the absence of itself. A black hole will have been born, and the legacy of darkness will flourish amidst the paradoxical silence of the void. For decades, its vast gas envelope had made it appear colder than it really was. more like a red supergiant. But that image revealed its true face, and with it a glimpse of the destiny written upon it. For such a massive star, the yellow hypergiant phase could last as little as 10,000 years, or as much as 100,000. A very brief period compared to its total lifespan, and merely a sigh on cosmic timescales.
Si WOH G64 se encuentra en una etapa post-supergigante roja tan inestable, muchos de los comportamientos extraños de la estrella podían ser explicados. Pero había uno que no, esa envoltura toroidal de gas. Algo tenía que estar ejerciendo una influencia gravitatoria sobre ella, y todas las pistas conducían a un mismo lugar, a la existencia de una hermana invisible.
Simulations suggest that the unusual behaviors of WOH G64 revealed by the image can be explained if the star is part of a binary system. It was proposed that hidden in the darkness of that empire there might be a sister, a dance partner for this giant on the brink of its demise. If a much smaller star exists, it could be exerting a gravitational influence powerful enough not only to prevent the formation of a spherical envelope, but also to contribute to the mass loss of its larger companion, ripping and tearing material from its surface. The mass loss, even considering the hypergiant phase, was far greater than expected for an isolated star. The presence of a second deity in this realm, through interactions involving material transfer and tidal forces, would increase the mass loss rate to match the observed values. Simultaneously, the sister would be shaping the material expelled by WOH G64, creating the complex asymmetric disk-like structure that seemed impossible to explain. Even the spectroscopic data, which suggested that the gas in the surrounding nebula exhibited different velocities, suddenly made sense within the framework of a binary system, with accretion flows and dynamic interactions driving the phenomenon. Confirming the existence of a stellar sibling in the system has become a focus of interest for astronomers worldwide. Being a much smaller body buried in a dense fog of stellar material 163,000 light-years away presents an unprecedented challenge in the history of astronomy. Future observations with the James Webb Telescope, searching for shifted spectral lines indicative of two bodies in mutual orbit, or refinements to interferometry systems like gravity, to directly discern two stellar sources in the region, could indirectly confirm its existence. We have not yet written the final chapter of what awaits in that ruined empire that may have long since ceased to exist, transformed into a memory etched in light.
No hay que olvidar que la estrella descansa 163.000 años luz de distancia. No la estamos viendo como es ahora, la estamos viendo como era hace 163.000 años. Es probable que WOH G64 ya haya explotado y que ahora mismo una onda de luz generada en esa supernova esté llegando a la Tierra, portando el último mensaje, el último lamento de ese gigante. Así que quizás en cierto sentido con ese retrato, la hemos devuelto a la vida.
Through that image, through the revelations extracted from a blurry snapshot, we have allowed this colossus to be reborn. For a fleeting instant, it forgets the dark air traversing the void and sees how, far from its realm, someone gazes upon its majesty one last time.